I'm going to talk about the 97 interleaving string. The question is given string S1, S2, and S3. Find whether S3 is formed by an interleaving of S1 and S2. An interleaving of two strings S and T is configured where S and T are divided into N and M substring respectively, such that this one, right? So the interleaving is S1 plus this one, or yeah, just use this way to generate the new S3 here. So it's kind of like use like the return result is booleans, right? So it will use like a DFS. I was treat it as like tree. And then we have the I and J. And to this is pick up J, and this is pick up I, and to go the button to generate whether it's matching for the S3. So this is the tree logic about here. So we have can matching something. M is equal to S2 length. And we have to make sure if they are calculated S1, right? S1 is this one. S1, how many? 1, 2, 3, 4, 5. Equal to 5. 1, 2, 3, 4, 5. And what the F3 is 5. So it's 10. So we have to check if numbers m plus m is not equal to the F3 length, but we actually can return false. Otherwise, return the DFS as 1, as 3, as 2, as 3. Okay, so if I smaller than 0, oh, this one should be from the last one. Then we could do it's a return true because we match it. Okay, current here boolean results. If the I is larger equal than 0 at the same time, so we pick up this branch as I char at I, whether equal to S3 char at I plus J. For example, A is B, A, B, C, C. I, right? And then for the Okay, so what's going next is A, B, B, C, and D, B, B, C, A. So for the, like, for here, right? And also we have the S3, A, D, B, C, B, C, B, C. Here is I. Here is kind of like the first is the 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we start from K here. So if current is larger than that, we have to check. So how could we know the, like, current I is equal to 4? So we have to check S3 is 4 plus 4. It actually is equal to 8, right? But for here, it actually is 9. So we need to plus 1. And if the DFS, we pick up the I, so minus 1, J has 1, has 2, has 3. Then we return true. Right now, for the S char at, now coming to the S2, char at J is equal to the S3 char at I plus J plus 1. Then if the DFS I and J minus 1 as 1 as 2 as 3, then we can return true. Check. Yep. So we actually update the result. But for the time complex is very large, so the space will 2 branch, right? It will be very large, and so space will be this one. So we need to improve that. We can use like we have the memory, because somewhere we current here maybe subtree is already checked, and for the right way also check again. You can see here. Yeah. So we can use the memory to improve the and M. And based on this one, we need plus 1. So memory here without force. Memory I J not equal to none, we just return memory. No need to go do the current deep seek something. return the directed return false. If we go to if we go to this way, we don't need this one. Member if not equal to ij. You should plus 1 here. And for the time is improve. Why this again? Parent square. Oh, and I see. It should be just the n times n. It will. Yeah, it should be improved in current way. It should be the TC is O n times m. TC is n times m. Use the memory way to do this. The recursion with the memory this way. This is a basic way. This input range equals to That's why we need to this, because when you treat it like a table here, there's a line called this is the columns, and for this one is called like empty, and for here is called empty, and for here is stored the index 0. So that's why we need to store the one of the I if this is kind of treated like I is equal to the -1. One of this is okay. we didn't do anything here. So that's why we need a +1. Yeah, thank you.